Hi, in this video, I will be covering the end-to-end machine learning cycle at one go. So in my previous video, you have been seeing me covering the individual components of machine learning lifecycle, but I thought I will use this video to show you the end-to-end lifecycle here at one go, starting from business to data understanding till the model deployment and model monitoring. With that, let's get started. So if you see this diagram, basically it's divided into the bottom part, that is what we call as a horizontal capability, and the top part, which are very use case specific. So when we say horizontal, these are a cross project capability. You don't want to build the infrastructure for each project. You don't want to create a pipeline orchestrator for each project. So basically you build these capabilities and you have multiple use cases that can come and leverage it. So to explain one component, model and application logging. So when you do an use case, right? You go through when you do an ML use case, you go through multiple iterations of model building and data pipeline and everything. So you want to log the iterations. Now, either I can create everything in my own project, Jupyter notebook or any IDE that we use and then log the metrics. Or what I can do is I can provide this as a capability where they can just come and import a package and then start logging it. What this does is this accelerates the ML lifecycle. So what we call in the bottom is kind of an horizontal capability, which is used cross project, across multiple use cases. On the top is where a machine learning lifecycle looks like. So this is very specific to an business use case. Say if I have a use case of fraud detection, my fraud detection use case will have its own life cycle of it. Say it's a use case for churn reduction, my churn reduction will have a life cycle of it, right? So let's get started from the left hand bottom, from the problem identification, and let's go all the way till the end. The very first step, right? And again, it's across the enterprise. It's the problem identification, right? ML is not a solution for everything. If you can do something without machine learning, that should be it. You must not really come to an machine learning or an artificial intelligence project at all. The easier the solution is better, right? But assume like you have a problem and you want to use ML. So what are the scenarios you want to use ML? First is check for scenarios where you want to scale, right? Say you are an insurance company, right? And you underwrite customers. And if you are going to underwrite under 100 customers a day, maybe you can have one or two people to really underwrite it. You don't really have to build an AI solution for that. But think if you're a company where you are underwriting thousands of customers, right? You might need some solution that can scale, right? That can be very fast, that can provide instant output to the end users, right? So basically you need to identify a problem where you can scale. It can be a problem where your existing rules engine has become very complex to manage, right? That and coding has become impossible because of your data pattern. Your data is getting more and more complex. You are tapping onto a lot of external sources, right? Those are the other scenario where you may have to think of, yeah, introducing machine learning. Or it can be critical to your business, right? You have to you have a lot of competitive pressure to innovate yourself. So that can be one of the reasons. So once you identify your problem, you prioritize the problem, and you pick an ML use case you want to execute. And for that ML use case, you start all the other cycle, starting on the business understanding. So the very first step for an ML project after you identify a problem is an business understanding. So business understanding is where you define and frame a business problem, right? If it's an existing business process, you try to understand how the business process works. What are the touch point of the business process, right? Say I am a credit card underwriter. I kind of see, okay, my application comes in through a web and it comes to my system, and my system has bunch of rules, right? And what does the rules do? How does it execute? What happens like if I'm not able to decision online? Do I go to offline review of the application? So you need to understand this end-to-end business process. That is in the business understanding space. Now the business understanding is also where you understand your business objective. What is your objective of this particular ML use case? So when I say objective, when I'm underwriting a customer, the credit card example I gave, I want to make sure I underwrite customers who have ability to pay. You will not default, right? So that is my business objective. Now my business objective can also be, I want to ensure, I want to detect fraudulent customers who come and open an account with the intention to not pay over time, right? So my intention can be to reduce risk and at the same time increase revenue, right? There can be multiple objective also. Now at this stage, don't confuse algorithmic objective to business objective. Your business objective must be plain and simple in business terms. I want to increase my revenue. I want to reduce my fraud. I want to kind of enhance my customer experience. Not I want to reduce the loss of mean square error or whatever it is. Not the algorithmic objective. This is a pure business objective. Now, once I have a business understanding, right? And business understanding is also a place where we define the success criteria of the ML project, right? The success criteria can be based on what we are currently doing. Say currently I'm executing a rules engine and I feel it's 70% accurate, and I can define, okay, I 70% accuracy is not enough. I want to kind of see what better I can get. It can be benchmark against some industry. So in case of like credit card underwriting, there may be industry benchmark of 80% accuracy, right? So basically you are seeing between the 70 to 80% what exactly you are gaining, right? For implementing this ML solution, and that's where the return of investment comes into play. So basically between the 70% to 80%, you are increasing the customer acquisition by 10% and reducing the default rate by 20%, which accounts to like $10 million, and the project cost you $5 million. Then you have a return of investment as starting as 1 year or 2 year. But say you are executing an ML project that's going to cost you $5 million and the cost of saving only is $1 million. So you need to see whether this project is really viable in a longer term, and does it give you a business advantage to really take it forward, right? So that's where the business understanding phase really helps, right? Next, you go to data understanding. Now you know the business understanding, you know the business process, you see the data footprints against this business process, right? So what we do is we gather knowledge on where data originates from, right? Where the data is coming from and how it gets processed in between. It can be a rules engine or it can be a completely new business process also you're trying to understand. It's pretty much possible. So you need to think about how the data will get processed in that scenario, and what decisions are currently made or what decisions are going to be made, and how the action is delivered to the end users. So in the data understanding, you track the data for the entire business process and see where the data exists, what kind of actions are taken out of the data, what are the multiple subsystems this data flows through. So that's about data understanding. Now, once you have this data understanding, what you basically do is you agree on a model SLA, right? Now, this is a very key important step. The reason is when you develop your model against a batch system, right? Your data is already stored in a warehouse or it's already stored in a data lake, right? It's a batch system. But when I have to deploy the model, I need to deploy it in a real-time system. So in the credit card example, the user comes in and submits its application online. As soon as the user clicks the submit button, you need to execute a model. So the model has to be responsive within say 100 millisecond or 200 millisecond. So you define an SLA. The reason is your training is different, your deployment is different. You need to account for your deployment during your training. If you are creating a very complex pipeline and you have an SLA of 100 millisecond and you have to process like 2000 transactions per second, there can be cases where you might have to do it. At that time, you need to make sure you will meet your SLA need, because even after you integrate your business process, if it does not meet your SLA need, the model is kind of not going to be of any benefit to you. So that's what they say. Model development is easy. Model development is very hard. Or rather, I would reframe it. Model development is hard, but model deployment is even harder, right? So next comes the data collection part of it. Now we understand our business, we understand our data. We go and collect the data. The data can be already collected and centralized, or we may have to go to the individual source system and collect the data that is required for our model. This is the data collection phase, right? Now, next comes data analysis. Now you have your data collected in a centralized space, right? In the data analysis phase, you understand your data better, right? You use descriptive statistics to get an bigger picture of your data, or you use inferential statistic to check multiple data set to make sure this data set is in line with what you are training, what you are testing, what you are validating. Because if you train with a model and test with a different model and validate with a different distribution altogether, right, you are not going to get the same performance metrics. So it can be also an exploratory data analysis where you do multivariate analysis or univariate analysis to check how this particular input futures behave against your target, right? And you also do analysis to see what additional transformations you can do to the data so that the data project provide the data the output is there is better outcome to it, right? Your model is better able to distinguish between a genuine and non-genuine user, or a user with a good credit score or not credit score, right? So basically, you kind of transform the data into a form that model can understand better, right? Many of your business problem can be enhanced. The accuracy of the model can be enhanced with pretty good data transformation and future engineering. So this part is very key. The data analysis part is very important. And once you have it, you feed your data transformation rules. So you tell your data engineer team, these are the kind of transformations I need to be done on the data, all right? And at the same time, if you see below, there is a data validation and anomaly detection phase. So what we do is, now you have your transformation, you collect your descriptive statistics and you store it, say for example, in an repository that I have connected to Health dashboard and alert. I think it is a repository. So I'm storing all my descriptive statistics over here. I'll come back to this, what I will do with that. Now, once I have my data transformation, the data analysis phase also is an input to the ML team, that is your machine learning engineer team, who derives additional features out of it. They further do they do further analysis on the data and they create features over there. Once the features is created and once the transformation is available, you train your model, right? You initially create a baseline model to see how the data responds to it. So basically, you have some baseline metrics, and then you kind of keep increasing the complexity of the model, or increasing testing with various algorithms, and see how this particular data set responds to different algorithms, right? You also do hyperparameter tuning to do the right hyperparameter selection. You kind of also do k-fold validation or cross validation to see which is the best model that you need to pick. You also do future selection. So all this happens in the model training and basically in the model training phase. So once your model is trained, you are done your feature selection, you are done your hyperparameter tuning, you are done your best algorithm selection, you go to model evaluation and validation. You take an out of time data set that the model has not seen, and then you evaluate the model and check whether the trained model is basically performing with an unseen data set or even with an future in time data set, right? So this is pretty important because the model may overfit your training data. You need to make sure you are kind of removing any bias in your trained model and everything, and that's where the model evaluation and validation phase comes place. And all of this process is completely iterative. It's not like you move forward to print. Sometimes you may have to go and collect additional data. Sometimes you may have to do more analysis on the data. You may run multiple iterations of your model training with new features added, new feature engineering done. Each of these are completely iterative process. Even though I have showed only one iteration, but each of the components are completely iterative. Now you have a model in place. So basically, you also develop your model explanation component. It can be a local explanation where you do an instance level explanation. So future, you get a serving input. You need to make sure, okay, you produced a score. You also want to make sure which attribute contributed to the score, right? So you are providing kind of an explanation to your each and every input inference point, right? Or it can be a global explanation. It can be just like a future importance over here, right? Now you create this, then you deploy your model. Now coming back to the SLA, right? Now you may have sometimes you may have to run your model batch nightly, right? You can take the same component and just schedule it nightly, but sometimes you may have to deploy it in the edge of the device, which is like an IoT device, and these are like low power, low consumption device. And Python may not be the best framework, or R may not be the best framework. Sometimes you may have to convert into C or Java, right? That is one aspect of it. Now, sometimes you may have to kind of respond in 100, 200 milliseconds. You can just flask it and deploy it as an REST service on a container platform, on a container orchestrator platform like Kubernetes. There are multiple ways of deploying it. I will be covering it in the detailed session. But for now, model deployment, it's not going to be what you get out of training. You will be able to deploy it as it is. You need to think about model deployment way ahead. You need to involve your software engineering team so that they are better prepared to deploy as per your system requirement and business process integration need. Right? Now, once the model is deployed, you start monitoring your model. Your model is very probabilistic, right? And in some kind of rapid business scenario change, your model can completely be non-performant. It may be just throwing out garbage score. So you need to make sure you continuously monitor your model, right? And that's where the two component, model drift analysis and data drift analysis, come into play. So what we do, I spoke about the data validation component that feeds into an dashboard system, or an that feeds into an health dashboard and a reporting system, which has a repository. So you collect descriptive statistics on each of the feature the final model was trained on, and those features you kind of persist the distribution over there. And in the data analysis drift phase, you compare the incoming data distribution that is coming in the real world, in the serving world, against the one that is stored. And if you see that the distribution is completely different, there may be some difference, that's fine, you need to set a threshold. If you see it's completely different, then that means your incoming data is drifted. Now you need to go back and do analysis why your data is drifted. It can be due to an incoming system error, or it can be really your business scenario has changed, right? So that's why you do a data drift. Your model drift is when you train and evaluate your model, you store your score distribution, model score distribution, and you compare it against the real world model score distribution. So all this comes part of a model monitoring. And what you do is you feed into a system that can continuously report and give output to a business user. See, the business does not understand the accuracy, recall, precision. So they need that KPIs. And those are the KPIs you define in your dashboard, talking about how the model is performing, how the incoming data is stable, and also more specifically going into the business KPIs on, okay, how much dollar amount did I save, how much this translates into revenue increase, right? So it's kind of a DevOps layer for the technical team. It's an information layer for the business team, right? So this kind of the end-to-end model development picture. I have one more slide where I will talk about the different roles that comes into play. So model development is not only an ML engineer or a data scientist activity. There are multiple players that get involved to make this project successful, make this project more scalable, and to generate a business value that is pretty consistent, right? When I say consistent, if you don't have the right team, you may end up in a spaghetti model code, which even you deploy it, it's very difficult to maintain over time. So you're not going to get any business value out of it. So basically, there are 4 different categories. The data engineering team is predominantly involved in the data collection, data transformation. They organize the data. They kind of create future engineering based on input from the data analyst and the machine learning engineer, right? The data analyst kind of does the data analysis work. They do the data validation across your multiple data set. It can be train, test, out of validation data set. They do the drift analysis, both model drift and data drift analysis. And they also provide input for future engineering. They provide the data cleansing rules or anomaly rules or whatever it is, right? The ML engineer predominantly works on future engineering. They work on model training. They work on model validation, and they work with the software engineering team and the data engineering team for the model deployment process, right? Because your pipeline has to come together, and that is the data engineering. Your model has to be deployed in a scalable environment. That is software engineering. A machine learning project becomes a software engineering project after it is trained. So the characteristics is very similar to any software engineering project. So that's what I said. Everybody has a role in this play. And finally, the software engineer helps in it's a software engineer, DevOps, or a BI engineer, depending on the complexity of the need. They help in model deployment, they help in model monitoring, they create dashboards, they monitor the dashboards, and they set up the alerting system. And that's about it. I'll be covering each of the component in more detail, but this just to give an end-to-end walkthrough of the machine learning process. Thank you.